Okay, checking work for 3-4, doing the even problems. Number 2, we were looking to maximize P for profit, we're going to say. Where did you find your profit maximized on number 2? Anybody tell me? Which vertice? 0, 4? And 0, 4 does give you 12. 2, 3 is close. It gives you 11. 5, 0 gives you 5. 0, 0 will give you nothing. On your test, you got to be able to list all of these vertices, show the graph, list the vertices, then pick the appropriate one that gives you your profit. So 0, 4 would have been the answer to this one. That was that line on the coordinate plane, that line on the coordinate plane, that's these two, and then y is greater than 0, x is greater than 0, those two lines.
I got 0, 6.
0, 6 is outside of our
I mean, no, not 0,
6,
6,
0,
It said 5, 0.
and that would have given you a different value, wouldn't it?
Yeah, so I got that.
Well, 6, 0 would have just given you 6 right here, wouldn't it? It's definitely angry now. Does that mean it's not moving? What? Means he's now just a weird shaped ball. No, it's not. Okay. Back to what we were doing. Thank you for noticing that. We're back after the angry bird fell off. Perfect. It was going to be. All right, number 4. For you guys, did you see where you missed, where you went different over here? If you guys missed this one, hopefully you see why you missed it or where you missed it. Number 4 we did together yesterday, correct? Okay, if you were gone, you can see this. We graphed this standard form equation, and we also graphed the fact that y was greater than 0 and x was greater than 0. Well, how did we find that intersection 1.2, 1.2? Somebody say it. Nobody knows. Where do we graph it? On our calculator. We found it right there. Right there on our graphing calculator, you can put those two lines on your graphing calculator and then ask for the intersection and it'll tell you. That was a lot easier than trying to eyeball it where those two lines intersect. This would be a good test question. This would be a good test question. All right, one more, number 6. 6, you have this line, x plus y less than or equal to 5, which is the same thing as this right here, y is less than or equal to negative x plus 5. So here's that line, starting at 5, going down. Did you do that? Negative 1 is your slope, starting at 5. The other equation was 4x plus y less than or equal to 8. Subtract 4x. We have this one right here. 8 is the y-intercept with a very steep down 4 over 1. Down 4 over 1. So this area right here was less than, so we were below that first line. This bounds it even smaller because we're also below that line. And like before, we are y greater than 0, x greater than 0, so we're in this little area. Here are the vertices that you should have found. 0, 0, 2, 0, 0, 5, and the last one is very seeable, 1, 4. That's a good test question, isn't it? I got 2, 0. You said you got 2, 0 instead of 3, 0? So did I. I got 2, 0 instead of 3, 0. So make sure you're very methodic about following this down 4/1. Either way, if you plug those into this cost, and it asks for the minimum, doesn't it? Isn't it kind of obvious which one's going to be the minimum? 0, 0 gives you 0. All right, go to the back. Just turn over. We're going to do number 8 on the back. Number 8 says, find the values of x and y that maximize or minimize the objective function for each graph, then find the maximum or the minimum value. We want to know the minimum cost, x plus 2y. So what value of x and y gives us the minimum cost? So first off, tell me my vertices. All of them are, we have a 2, 7. Right there. No, 2, 7's right there, isn't it? What's next?
4, 0.
We have a 4, 0. What else do we have?
2, 7.
We got 2, 7.
Sorry, 8, 3.
8, 3. What else do we have? 0, 3. Which one of those is the winner? What did I hear? 2, 7 is not the winner. 4, 0 is 4. 4 in for the x, 0 in for the y gives us 4 plus 2 times 0. 4. Can any of these others be smaller or a minimum than 4? No. So 4, 0, that's point D, would be the answer to that question. That's a good question. All right. Now we're going to do number 10 right here. So you guys keep track of 10. Sorry. Number 10 we're going to do in the back. Or you can do it on yours right on the side. I just need room. 10 talks about making 2 types of desserts. A weird named cake and what else? A bread and a cake. Irish soda bread and a what? I'm going to say a K cake. Y'all cool with that? I can't say that word either way. And we're gonna be able to make some money off of these, right? How much are we selling them for? Let's make a profit function.
$1.50.
Which one's $1.50?
Irish soda.
Okay. So you make $1.50 for every Irish
Soda brand, sorry.
ISB. Y'all cool with that?
And $4 for each cake.
$4 for each cake. Y'all cool with that? So which one do you want to sell more of? Potentially the cake. But the cake requires something more. What does it require more of? More ingredients. So some of the constraints. Let's talk about how much it takes to make a bread. Bread takes how much? 2 cups flour, 1/4 cup sugar. So not much to make the bread. What about the cake?
16 cup flour and
No, how much does it take to make the cake?
4 cup flour and 1 cup of sugar.
Oh my goodness, it takes twice as much flour to make the cake, but 4 times as much sugar. So you can sell it for more, but it takes more to make it. The sugar becomes a constraint, doesn't it? Because how much total flour do we have?
16.
So boom, right there. If I just went cake, I can make 4, couldn't I? How much total flour or total sugar do I have?
3 cups.
Uh-oh. So I can't even make 4 cakes, can I? Because every cake takes a cup of sugar. After 3 cakes, I'm out of sugar. Sugar. What if I went the other route? What if I made bread? I can make, according to my flour, this is a constraint here, I can make 8 breads. What's a fourth of 8? 2. So I wouldn't run out of sugar then, would I? So if I just went straight bread, I could make nothing but bread. I can make 8 of them. Y'all agree? 8 at $1.50 would be how much? 12 bucks? So if I did 8 breads, y'all agree? If I did 8 breads, what would I have left over again? How much sugar? 1 cup, right? And I would have what did we say we'd make? $12. I did that backwards, $12. So 1 cup of sugar left over, 12 bucks. So that's one way of thinking about all your constraints here, like what you could potentially do. If we said we could make 3 cakes before we'd run out of material, and if we did 3 cakes, that'd be all of our sugar, and we would still have 4 cups of flour left over. How much money would we make? 12 bucks still, right? So if you go all of one or go all of the other, you are not, we don't feel ourselves making more money one way or the other. So what if there is a combination of the two? What if there's somewhere we could work where we make a little bit of each? Well, let me show you how you can make some equations. If we say x equals our we'll say well, let's talk about x could be our number of breads we make, and y could be our number of cakes we make. We can make a couple constraint equations. Let's make an equation over flour. Remember how much flour do we have altogether? So we have 16 cups of flour. And if I take my bread and my cake and add it together to get to that 16 cups, what value do I have to put by the bread? It's supposed to be a bread. How many cups for every bread? 2 cups for every bread. How many cups of flour for every cake? So if we take 2 cups for every bread and 4 cups for every flour and add them together, it's got to be, actually it's got to be less than or equal to 16, doesn't it? So that'd be a constraint that we built out of some real scenario. Well, let's do one for our sugar. Our sugar's got to be less than or equal to 3 cups. How much sugar do we use for each bread? 1/4 cup? How much sugar do we use for each cake? 1, right? So just understood 1. So 1/4 cup of sugar and 1 cup of sugar. If you add these two together, it's got to be less than or equal to 3. Hey, let's look at this. Go to your calculator. Show you a nice little trick. Go to a graph. Go to a graph. Let's put these constraints on your graph. Maybe we can find something that'll work. So go to menu, graph entry, and let's do 2 an equation, 1 of a line, and I'm going to cheat here. Guess what I'm about to do? Standard, number 3. I'm just going to keep it like it is, okay? First time we've done it in this class. Our technology allows us to put in a standard form equation. That's what we got. Heck, let's just do it. We're going to put in our flour constraint equation. 2 for every x, tab, 4 for every y. It's got to be, I don't care that it's an equal to, so I'm just going to leave it to less than or equal to 16. Enter. There's what that line would look like if you were moving across. This is the combinations of x and y that would keep you around 16. Let's do that for our sugar. Maybe if we put both of them on there, we can see where they intersect and find an area that we can work in. Another graph entry, another equation of a line, and I'm going to cheat with standard form. Say 1/4 of a cup of sugar plus 1 cup of sugar has got to equal to 3 cups of sugar. And they do cross. One of my morning students pointed out, if you come up here, Mr. Bush, and hold down, there's a way of getting that. There we go. I can grab those things and move them out of the way. Did y'all know y'all could do that? When the hand grabs, I'm just going to scoot those labels out of the way. Okay, so now I see my intersection. Actually, I'm going to do this too. I'm going to go menu. I'm going to go to zoom, quadrant 1. Get in there a little bit tighter. Oh, I don't even like that. I want to, well, that's good enough. I'm not going to waste any more time. We see the intersection right there. So, what am I going to do? Somebody tell me the buttons I push from now on. Menu. 6 to analyze graph. 4 for intersection. It's asking for a lower bound. So anywhere below the intersection, hit enter. Pan across. Oh, looky there. Look at this combination of x and y. What is this combination of x and y? 4 bread, 2 cakes. Let's talk about money over here. What if we did? Let's go back up here. 4 breads. This Irish soda bread. What's 4 times $1.50? So that'd be 6 plus, what's 8 times 2? I mean, 2 times 4. 8. 8 and 6 gives us 14. Yes, so $1.50 times 4 plus $4 times 2 gives us, what'd y'all say, $14? That's where we maximize our profits. That's the area that the constraint equations show you can work in. You could also, these constraint equations also show you how you would be bound right here. What is that? 8. If all you, I think this blue one is the 2x plus 4y. So that's if you did nothing but Irish soda. You could do 8 x's. You see that gap in behind there showing leftovers. If you come over here to the red line, its y intersection, go 3 y's. It shows you, you probably had some x left over. Kind of cool, isn't it? I got to be honest with you guys, I looked at this problem a lot of different ways. You could make a table, you could mental math it. I like looking at these 2 constraint equations and then finding that intersection to help you find where to maximize your profits. All right, good job.